In this video, we are going to see about hashing. We will be seeing about what is hash function and how the collision occurs there and how to resolve that hashing. All these things we are going to see in this video. So first we can see what is hash function, and hash function, it maps the arbitrary data size to fixed size data. So from this we can calculate the index value to find the particular value of the index. So the formula for that, it is here, it is given. Index is equal to hash function of key modulo array size, and this is the diagram for that. See here. So this is the hash function and these are the keys. So for each keys, the hash function is calculated, and from that the index value is found, and finally you'll be getting the values of the specific hash key values. Okay. So the main concept of this particular thing, it is mapping the large data set to a smaller fixed size of indexes. So from that easily we can find the particular needed value. And here next we are going to see about some hashing methods. So various methods are there. So the first method, it is division method. So using the division method we can calculate the hashing value and finally find the location for that. It is the easiest way and quickest way, and this is the formula h of k is equal to k mod m. And here this is one example. K value is given, m value is given. Finally we can find the h value, and it is 4. And so that in that indexes, in the that particular 4 is the hash function hash value calculated for the given value, so that we can use the location. And some advantages and disadvantages are there, since it is very fast and effective for all em values. We are having an disadvantage also. Consecutive keys map to the successive value. So poor performance if the m is not chosen carefully. So it is very important to find the m value. And the second method is mid-square method, squaring the value of k, that is k into k. Okay, so use the middle digits as the hash value, and using that we can find the hash value. So see here k, and this is the k into a, hashing of k into k, it is 60. And here also we are having some advantages and disadvantages. And so not nominated by top or middle digits, and large keys create very large squares, and so it is considered as the disadvantage. And the next type, it is folding method, dividing the key into pieces of equal size and then adding them together. And here it is separated as equal size and finally adding them together, and it is called folding method. And some characteristics it is given there. It creates simple hash values by splitting the keys. Since it is a big key value, even if it is a big key value, we are separating in equal sizes, so it will be easier to handle. It ignores the distribution in the hash table. Efficiency suffers if too many collision occurs here. Okay, and then the next method, it is multiplication method. So this is the procedure for that. Select a constant value, multiply the key value with the constant value, take the fraction point, multiply again by the table size, and finally take the floor value. And here this is a function, that formula for that. Okay, first of all we want to find the k modulo, and then we have to multiply with the m, and finally we have to find the take the floor value of that, and finally using that we are finding the hashing value. And this is the example. Okay, so those are the methods for finding the hash values. And here we can see how to create the hash table structure. And what is hash table? A data structure that stores the key value pair. That is the hash table. So this is the hash table. It uses a hash function to compute the index into an array of the buckets or slots. Okay. So key value, using the key value pair, the cache function is found, and that particular table where the key value hash function is there, that we will be calling it as the hash table. So this is the value, keys and hash function. Okay. So using these things we can see the flow of the hashing done. Okay. So this is the input value, and this is the hash function for calculated for that input values, and here it is the hash keys, and from this hash keys we can find the indexes, and finally the values in the indexes will be found, or else we can store the values in such indexes. And next we can see the collision. So we all know what is collision. Okay, so I'll explain you what is collision. That is, we know how to find the hash value. So in case if two or more values are getting the same hash values. Okay, so in the same indexes we can't put the same values there. Okay, for, if you see the previous diagram, so this is a hash values. Okay, and 0 is there, and again for another value we are getting the hash value as 0. So what happens, it is difficult to put the same value in this particular location, so collision occurs. So in such situation, we have to handle that. Okay. So we are going to see the techniques to resolve the collision. Okay. So this is hash of k value and hash of key if both are equal. So that we want to choose the same hash, that is same index value, right? So collision occurs, and we are going to see uh, the various types to resolve the collision. Here the first type, it is separate chaining. Separate chaining is the first type for resolving the collision. Okay, and to calculate the hash value, hash function, and see here there are the three values. 75 is one value, 81 is one value, and 63 is one value. So when you are calculating the hash function for this 75, we will be getting 3. Again, if you are calculating for 81, we are getting 3. For 63, it is getting 3. So what happens is, all these three values are getting the same index as 3. So it is necessary to put all the 75, 81 and 63 in the same location. So what happens? Collision may occur. So instead of putting that in the same location, we can create a chain. So that is, from 81, 63, it will be chained in the same index 3. So first of all, in the index 3, 75 will be there. In the same index, we are going to create a chain, and we are having 81 there. Again, we are creating a index, we are having 63 there. Okay, so in the same index, in the 75 we are creating here we are creating 81, then again we are creating 63 there. This is called a separate chaining method. So this is a one way collision can be resolved. Okay, and another one method is there, that is called linear probing method. So linear probing, if the collision occurs sequentially, check the next slot, index plus 1, until an empty one is found. Okay, so in the first value collision is there, we can go to the next slot, that is index plus 1. Again the same collision occurs, we want to go to the next slot, collision index plus 2, like that. Okay, this is the formula for the linear probing. H of x is equal to hashing of x plus I modulo table size. Okay, and here one disadvantage is there, that is blocking blocks of occupied cells forms. Okay, so what happens is increasing the search times, and this is the example for the linear probing. Here the table size, it is 10, and f of I it is considered as a 1, and so hash value is found using this formula, hash of x plus I modulo table size. Table size is given as 10, and I value starts from 1. So 79 plus first 0th index modulo 10 is equal to 9. Okay, so we will be getting the index value as 9, so that no issues, we can put the 79 in the index value 9. Again, if you are calculating the second, for the second value 28, we are calculating and we are getting 8, so 8 becomes the index value. We can put the 8 values in the 28 in 8, no issues. And when you are coming to calculate the third one, that is the value 39, we will be getting the index value as 9, as it is already occupied by 79. If you are putting the same there, collision may occur. So we are going to change this 0, I is equal to 0 here. So here we are going to calculate I plus 1. So I plus 1 is 1. So what happens is, now again we will be calculating this hash value. We will be getting 0. So no issues. In the 0 we can locate the position. And here the value it is 68. So when you are calculating first, it will be getting 8 occupied, again 9 it is getting occupied, again 0 it is getting occupied, and finally here the I becomes 3. So see here, f of I is equal to I. This I starts from 0. Usually I value we are getting 0, giving 0. If once occupied, the I value it is changed to 1. So here also it is 0. Once occupied, we are giving to 1. And again occupied, we are changing to 2. Again occupied, we are now changing to 3. Okay, 68 plus 3 modulo 10, we will be getting 1. So the place is not occupied, and here we are putting the value 68. Now 89. So 89 hash value we are calculating 9. It is, we are getting 9 occupied, 0 occupied, 1 occupied, and here also we are coming to f of 3. I value changed to 3 and we are getting 2. So 89 it is located in 2. So this is the way we are resolving the collision using linear probing method. Okay. And the next one, it is quadratic probing. So it eliminates the clustering by using a quadratic polynomial. The formula for that, it is h of x is equal to hash of x plus I square modulo size. So this is the difference between quadratic probing and the linear probing. Only the difference is I square. There the formula we have seen I, here it is I square. Other than that, everything it is same. We can see the example here too. The same, the using this table size is 10, the value is 79, and 0 square we can find the value. Index value it is 9, and same 0 square, index value is 8. Again we will be getting the 9 occupied, and so this 0 changed to 1 square. We will be getting the index value as 1. It is occupied here. And for a 68, 8 at first value it is occupied. Now we are going for 1 square, it is occupied. Again we are going for 2 square. Now we found on 2 second equation, and here we are locating 68. So only the difference between quadratic probing and linear probing is that square. And here double hashing, the formula is something different. Hashing of x plus I into hashing, second hashing of x modulo size. So when we are not getting the location in the first hashing, we want to go for the hashing 2. So see here 79 is the value. 79. First of all, we are calculating the hash value 79. We will be getting 9. We can locate it there. And for the 8, we are getting, it is located there. For again 39, collision occurs. So that what we are going to do, it is we are calculating the calculating the second hashing there. So see here, second hashing is calculated using the table size. See here, x modulo 10 for the first hashing, and this is for second hashing. and finally we will be getting the value there. And for 68, 8 in the set first hashing we will be getting 8 and it is already occupied, and finally we will be getting the value as 0, and this is the location for that. So see here in this video h1 so this is the formula for that. First hashing, second hashing, and the size required we have to calculate the h1 for the double hashing, and this is the first hashing formula, and this is the second hashing formula, and this is a f1 we need to we need for calculating the hashing value. So first of all, f1 will be the same I into h1 of x, and when we are going for the double hashing, this value will be changed. So using this, we are writing here h1 of 79, it's 9, h2 of 79. Using this, we can calculate. Okay, so finally we will be getting this one. And similarly for all the key values 79, 28, 39 and 68, we have to calculate this. If found in the first step it is okay, otherwise we have to go for the second hashing here, so that we will be getting these values. And finally rehashing. So resizing the table and recalculating the indexes of all the entries, that we will be calling it as rehashing. So whenever we are not getting the values, we can go for these calculations. Okay. So in this video, we have seen hash function. What is hash function? What are the methods for calculating the hash functions? And then we have seen about collision, and what is collision, how to resolve the collision, separate chaining methods there, and quadratic probing, linear probing, double hashing. Using all these techniques we can solve the collision. So all these things we have seen in this video. Thank you.